So for today's video, I wanted to do sort of a review of finding the domain of functions, which we kind of already talked about in class, but sort of the harder versions of it, right? So the harder looking equations and how we can tackle figuring out the domains, because this is always a topic that for some people just doesn't really sink in right away. So I wanted to do a video real quick to sort of just like go through several examples for practice. I think I have 5 or 6. Okay, what I recommend you do if this is a topic that you may not necessarily be that great at, once I put them up, pause the video, try to write the domain down yourself, and then watch me sort of work through it and make sure your answers are correct. That would be my recommendation. Okay, but again, this is good preparation for the quiz that's coming up. And yeah, we kind of already talked about the basic concepts of domains of functions, right? The 2 cases where your domain will be restricted, which is if you have a denominator, it can't be 0. If you have a square root, you can't take the square root of a negative number. But I just, again, want to practice some sort of trickier ones. Okay, so let's jump right in here. So here's my first function I want to take the domain of. Okay, and at first glance, you might say, well, I could stare at that for a while and I wouldn't be able to figure out what the domain of that function would be. Okay, but remember, there's only 2 things that could restrict your domain, and one of them is the denominator can't be 0. So this denominator here, this x squared plus 11x plus 24, that is not allowed to be 0. What I recommend you do, okay, well, other than pause right now, try it yourself. Okay, what I recommend that you do is you actually take this denominator here and you say that is not equal to 0. So you set up an inequality just like this, and then you solve it the same way you would solve an equation. So in order for this to not equal 0, well, I factor it into x plus 8 and x plus 3. Well, if this is not equal to 0, that means x cannot be negative 8 and x cannot be negative 3. Those are the 2 values that will make my denominator 0. So those are the 2 values that are eliminated from my domain. Any other value of x is perfectly fine, except for negative 8 and negative 3. And again, you can check those, plug them in here, and confirm those will make my denominator 0, which is why they are kicked out of my domain. Okay, next example, something like this. So again, pause for a second, see if you can figure out the domain on your own. And now I'm going to talk through the same process. Okay, again, there's a denominator. The denominator can't be 0, so I'm going to set up that inequality. X squared plus 4 is not equal to 0. Well, if I subtract 4 from both sides, I can see right away there's no way I could have x squared be equal to negative 4. Whenever I square a number, I end up with a positive number, right? So even if I try to take the square root of both sides here, for example, I would end up with the square root of a negative number, which is impossible. So this denominator actually is always going to be a positive number. Any number squared is positive, and then I'm just adding 4 to it, so it's getting bigger. So this denominator can never be 0. That means the domain of this function is actually all real numbers, okay? Because there is no value of x that would make that denominator be 0, okay? Next example, I have this one, f of x equals 1 over the square root of x minus 7. So again, pause and try it on your own first. In this case, I actually have 2 different things I have to keep track of. One of them is I can't take the square root of a negative number. So this thing inside of my square root, this x minus 7, has to be positive. But I also have to keep track of the fact that my denominator can't be 0. So I set up 2 different inequalities. One of them is that x minus 7 has to be greater than or equal to 0. That's what makes this, the inside of the root, be a positive number. The other is that the denominator itself cannot be equal to 0. Okay? Well, it's pretty obvious that if I add 7 on both sides here, I get x is greater than or equal to 7. And the only way that this could be equal to 0 is if the inside was equal to 0, which would be when x is equal to 7. So my domain in this case is x must be greater than or equal to 7, and x cannot be equal to 7. So the only way I could write this sort of as one inequality would be x is greater than 7. Okay, because x is greater than or equal to 7 to make the square root be of a positive number, but x can't be 7 also, because if x is equal to 7, then I divide by 0, right? The 7's cool for the square root part. It just doesn't help. It doesn't get included in my domain because it makes my denominator 0, and my denominator can't be 0. Okay, if the square root of x minus 7 were in the numerator, then it would be no problem. But because it's in the denominator, I have to eliminate 7 as well. So this domain is actually very similar to a lot of square root domains we've seen, but just slightly different at the same time. Okay, take a look at this one. So this one's got all kinds of things going for it. So pause for a second, try it on your own. Just like in the last one, I'm actually going to set up 2 different inequalities because I see 2 different places where my domain can be restricted. One of them is this inside of my root has to be positive. I can't take the square root of the negative number. And the other is that the denominator itself cannot be equal to 0. So that gives me sort of two different inequalities to solve. One of them is that 6 minus x must be greater than or equal to 0. And one of them is that x squared minus 4 is not equal to 0. Well, I'm going to try to solve both of these at once. I'm going to subtract 6 from both sides over here. That gives me this. I'm going to add 4 to both sides over here. That gives me this. And then if I divide this by -1, I have to remember to flip the sign. And then over here, I'm going to take the square root of one side, the plus or minus square root of the other. So now I have 3 different restrictions on my domain. X has to be less than or equal to 6. If it's not, this numerator is going to have an issue because I'll be taking the square root of a negative number. So that's the first thing. X must be less than or equal to 6. But it also can't be 2, and it can't be -2, because either of those values would make my denominator 0. So altogether, this is my domain. X is less than or equal to 6, and x is not equal to 2 or -2. Okay, one last example, which should call back to something that might be a skill you remember from the previous chapter, or hopefully you remember it. If f of x is equal to this, the square root of x squared minus 4x minus 5. So pause for a second, see if you can figure it out. This is a really good example of one that I think no matter how long you think about it, you're not going to be able to sort of come up with this. Oops, sorry guys. You're not going to be able to come up with this domain without doing some kind of math, some kind of inequality that you have to solve, right? And of course, the inequality that you're looking for is this inside of my square root has to be positive. So I'll set that up like that. That is a quadratic inequality. Now, hopefully you remember how to do quadratic inequalities from the last chapter. I'm going to factor it. Okay, so this factors into x minus 5 and x plus 1. Okay, and now from here, I know that I have my two boundary values of 5 and -1, but I can't decide if I'm going to be greater than 5 or less than 5 or greater than -1 or less than -1 without making a sign chart. So I bring in a number line. I'm going to label my boundary values at -1 and 5. And now I'm going to pick test points in each of these areas to see if my function, my polynomial, I should say, my quadratic here, is positive or negative. Remember, I want the values that make this x squared minus 4x minus 5 be positive. I could plug into this top one here, but it's actually usually easier to plug into the factored form. So let's start with the number back here. Let's say, I don't know, -4. Okay, that would make this -9 and that -3. So a negative times a negative is a positive. So this over here is where one place where my quadratic is a positive value. If I pick a number between -1 and 5, let's go for 0. That gives me -5, +1. Negative times positive is negative. So this would not be part of my domain, right? Because in between here, this polynomial has a negative value and I can't take the square root of a negative number. And then finally, for the last section, I'll pick like 7. 7 minus 5 is 2. 7 plus 1 is 8. 2 times 8 is a positive number. Okay, so it looks like my domain is going to be x is less than or equal to -1, or x is greater than or equal to 5, because those are the values where the inside of my radical gives me a positive number. Okay, so this sort of calls back to some stuff from the last chapter that hopefully you have some recollection of. Okay, so those were all the examples I have for finding the domain of a function. These are really about as hard as we can go right now. Remember, as the year goes on, we'll find some more restrictions that are two domains other than just square roots of negatives and dividing by 0. But for now, it's sort of the same process all over and over again. You got to look at the function, think about what might restrict the domain, set up an inequality, and then solve it. Okay, that's all for me. See you tomorrow.